Welcome, everyone. Today, we are going to embark on a deep dive into the foundational definition of cloud computing. Let's get started. Let's begin by defining cloud computing. At its core, cloud computing is the delivery of computing services over the internet, often simply referred to as the cloud. Think about the computing services you use every day, like servers, storage, databases, and networking. Historically, you'd need to buy physical equipment to run these. Today, cloud computing delivers them all online. As we see in our first bullet point, this fundamentally changes how we approach IT. It removes the constraints of physical infrastructure, meaning you don't have to wait weeks or months to build a new data center to expand your capacity. Instead, you get faster innovation, highly flexible resources, and the advantages of massive economies of scale. You are essentially renting compute power and storage from someone else's data center. Looking at our diagram, you can see cloud computing positioned at the top. The central mechanism is the delivery over internet. Branching off to the right, we define what exactly is being delivered: computing services. This encompasses foundational elements like servers and storage, extends to databases and networking, and even includes advanced intelligence and analytics. By moving these services to the internet, the entire model shifts, leading us to the left branch. Here we unlock the ultimate goals of the cloud: faster innovation and flexible resources. The diagram visually represents how shifting from physical hardware to internet-delivered services expands what a business can quickly achieve. To truly grasp the definition of cloud computing, we must contrast it with traditional IT. In a traditional corporate data center, your company is entirely responsible for maintaining physical space, ensuring security, and buying servers. This requires a massive upfront capital expenditure, or CapEx. Cloud computing completely revolutionizes this approach. As our second point highlights, cloud computing converts that heavy CapEx into an operational expense, or OpEx. Instead of buying hardware, a public cloud vendor takes complete responsibility for purchasing and maintaining the servers. You simply lease whatever hardware and software services you require on an as-needed basis. If you only need a server for 2 hours, you only pay for 2 hours. This shift from physical ownership to leasing is a defining characteristic of cloud computing. This flowchart contrasts traditional IT with cloud computing. On the top path, traditional IT requires CapEx, large upfront costs leading to owning hardware, and the heavy burden of managing the data center yourself. The bottom path illustrates the cloud computing definition. Notice the shift to OpEx. Here, you lease services on demand. Furthermore, the hardware is maintained entirely by the cloud vendor. The dotted lines with X's represent the breaking of the old paradigm. You no longer have to own the hardware, and you no longer have to manage the physical facility. The cloud provider takes on the heavy lifting, freeing you to focus on your actual applications. Why does defining cloud computing matter so much to modern business? It comes down to a few core benefits that define its value proposition. First, the cloud typically operates on a pay-as-you-go pricing model, which helps you dramatically lower your operating costs by paying only for what you use. Second, cloud services are provided self-service and on-demand. This means vast computing resources can be provisioned in minutes, giving your business incredible speed and flexibility while taking the pressure off capacity planning. Third is elastic global scale. The cloud allows you to deliver the exact right amount of resources, like computing power or bandwidth, right when they are needed, from the optimal geographic location. Finally, because cloud providers operate massive, decentralized networks, they offer high reliability. Data can be mirrored at multiple redundant sites, making disaster recovery much easier and less expensive. This diagram breaks down the why of cloud computing into 4 foundational pillars. Starting from the center, we branch out into cost efficiency, speed and agility, elastic scale, and high reliability. Under cost efficiency, we highlight the pay-as-you-go model, which is the financial heartbeat of the cloud. Speed and agility are achieved because you can provision in minutes, bypassing long hardware procurement cycles. Elastic scale allows you to scale resources on demand to match your exact traffic. And finally, high reliability is secured through redundant global sites, ensuring that even if one data center goes offline, your applications stay running. Let's deep dive into how cloud computing actually works behind the scenes. While it feels like magic, it is built on massive physical data centers located around the world, organized into regions and availability zones to ensure resiliency. The secret sauce of cloud computing is virtualization. On each physical server in a Microsoft Azure data center, for instance, a hypervisor runs directly over the hardware. This hypervisor acts like a microkernel, dividing the physical node into multiple isolated guest virtual machines, or VMs, and securely managing their access to the underlying hardware. This means that user instances operate as standalone virtual machines without direct access to the physical host server. Finally, users access these abstracted, highly scalable compute resources securely over the internet. You never interact with the physical box, you only interact with the virtualized resources. Let's walk through the architecture shown here. At the top, we have the cloud data center, which houses thousands of physical server nodes. On a single server node, the crucial component is the hypervisor. The hypervisor sits above the hardware and slices it up into multiple isolated environments, labeled here as guest VM 1, 2, and 3. Notice the user at the bottom. The user connects over the internet directly to their assigned guest VM. The user never touches the physical hardware or the hypervisor. The hypervisor ensures total isolation and security, preventing one user's VM from interfering with another's. This abstraction is the mechanical definition of cloud computing. When we define cloud computing today, we must look beyond basic servers and storage. The cloud has evolved into a vast ecosystem of services. While renting virtual machines is known as infrastructure as a service, or IaaS, the cloud expands much further. Providers offer platform as a service, or PaaS, which supplies an on-demand environment for developers to build, test, and deploy applications without ever worrying about the underlying infrastructure. Then there is software as a service, or SaaS, where fully functional applications are hosted, managed, and delivered directly to users over a web browser. Moreover, the modern definition of cloud computing includes access to cutting-edge capabilities like Internet of Things, data analytics, machine learning, and advanced artificial intelligence. The cloud democratizes access to these powerful tools. This diagram illustrates the expanding scope of cloud computing. From our central node, we branch into the core service models, IaaS, PaaS, SaaS, and advanced services. IaaS covers the foundational VMs and storage. PaaS abstracts the infrastructure away entirely, providing app development platforms. SaaS moves even higher up the stack, offering fully hosted software ready for end users. Finally, the advanced services branch highlights how the cloud delivers transformative technologies like AI, ML, and IoT directly to businesses. This visually reinforces that defining the cloud today means defining a comprehensive platform for almost any IT or innovation need. Let's dive deeper into one of the most critical aspects of the cloud computing definition, the consumption-based model. Unlike traditional IT, where you must estimate future resource needs and buy hardware in advance, often leading to wasted money if you overestimate, or poor performance if you underestimate, the cloud operates entirely differently. Because cloud computing falls under operational expenditure, or OpEx, you only pay for the IT resources you actually consume. If you deploy 10 virtual machines today and delete them tomorrow, you are only billed for the hours they were running. You don't pay for the provider's electricity, security, or idle capacity. This consumption-based model means you can scale resources up precisely when demand spikes and instantly scale them down when demand drops, ensuring extreme financial efficiency. Here we visualize the consumption-based model in action. From the top, our cloud environment constantly monitors demand. If demand increases, the cloud dynamically allows us to scale up resources to maintain performance. Conversely, if demand decreases, we can easily scale down resources. Both of these paths funnel directly into the ultimate financial benefit: pay only for active use. This continuous, elastic loop defines the economic power of cloud computing, completely eliminating the rigid, static hardware costs of the past. To cement our understanding, let's explore a very important real-time use case. Imagine an e-commerce company preparing for a massive holiday shopping spike, like Black Friday. In the traditional data center model, to survive this spike, the company would have to purchase a huge amount of expensive hardware. The problem, for the other 11 months of the year, those servers sit idle, wasting capital and electricity. Enter cloud computing. By utilizing the cloud, the company configures an auto-scaling rule. As user traffic spikes on Black Friday, the cloud automatically deploys additional virtual machines to handle the exact load, preventing site crashes and ensuring a seamless customer experience. Once the holiday rush ends, the cloud scales those resources back down. The company only pays for that massive compute power for the few days it was actually used. This is the true definition of cloud computing in action. This sequence diagram maps out our real-world use case during a traffic spike. The user initiates a massive traffic spike, hitting the cloud load balancer. The load balancer detects the strain and sends a high CPU alert to the autoscaler. The autoscaler instantly provisions new virtual machines to absorb the load. Once ready, the load balancer routes traffic to them, resulting in a seamless experience for the user. Later, the note shows traffic drops. The autoscaler detects this and immediately deprovisions the extra VMs. The final note highlights the result: costs reduced. This sequence perfectly encapsulates how the cloud seamlessly handles real-world volatility. Let's summarize our deep dive into the definition of cloud computing. In simplest terms, cloud computing is renting compute power, storage, and advanced services from someone else's data center, delivered securely over the internet. It fundamentally transforms the business of IT, shifting rigid, upfront capital expenditures into flexible, pay-as-you-go operational expenses. By doing so, it completely eliminates the burden of purchasing hardware and managing physical data centers. That responsibility shifts entirely to the cloud provider. Ultimately, cloud computing is defined by the capabilities it unlocks. It empowers organizations of all sizes to innovate rapidly, scale their operations globally on demand, and achieve enterprise-grade reliability and security. That concludes our definition and deep dive into cloud computing. Our final diagram serves as a comprehensive summary of the cloud computing definition. The central concept, define cloud computing, breaks down into 4 defining characteristics. Delivery over internet gives us global access. Pay-as-you-go OpEx provides unparalleled cost efficiency. Provider-managed hardware relieves the IT burden so teams can focus on app dev and core business needs. Finally, elastic scalability drives agility and innovation, allowing businesses to respond instantly to market demands. By keeping these 4 pillars in mind, you hold a complete, real-world understanding of what cloud computing truly is.